Good afternoon. Today we are continuing on with CO10. I can apply the order of operations on expressions with those rational numbers. And we talked about rational numbers, right? It can be positive or negative, they can be fractions or decimals that end or repeat. So, using your best movie voice, I don't have a good movie voice, imagine a world without rules for solving equations. We didn't have rules to solve those equations, would we all come up with the same answers? No, because we would use our own rules and we'd get different answers. So look at 3 plus 4 times 7. I see two different answers given. One says 49 and one says 31. Are they both right? Can we have different answers for the same equation? No. Which one is right? Without the order of operations, one can make a case that either is correct. But because of that order of operations, we know which one is the correct one. Figure out which one it is. I'm going to give my friends a moment to look who didn't have a chance yet. Which one do you think, LJ? Why would it be 31? Multiplication and division is done first before we add or subtract. So 4 times 7 is 28. 3 plus 28 equals that 31. Over here they did 3 plus 7. Sorry, 3 plus 4 is 7, times 7 is 49. They just read it straight across. You can't do that with the order of operations. Some of us are learning the hard way with that 5-card challenge, that you really have to pay attention to those order of operations. Make sure that we are putting things in the correct way, using parentheses if we want to add before we multiply, right? So, what is our order of operations? Does anybody know the little acronym that we use? So, Mr. Robinson teaches PEMDAS. What do you think Mr. Schultz teaches? It's not PEMDAS. What do you think Luke? PEMDAS. Because I put that in for your Khan Academy passwords. So we get used to thinking in terms of PEMDAS instead of just PEMDAS. Now, Mr. Schultz, he will argue up, down, and all around that it should be PEMDAS. And he can go into detail on it. I'm not going to do that. But I am going to show you what it means. So if we have PEMDAS, what does the P stand for? Parentheses. That is the very first thing we do. If there are any parentheses in our equation, we do what's inside of the parentheses first. And inside that parentheses, you still follow the order of operation. So if they had 3 plus 4 times 7 inside of parentheses, you would still have to multiply first and then add. Okay, so inside parentheses, you still follow the correct order of operations. What does the E stand for? Natalie? Exponents. Come with that tricky R. Instead of PEMDAS, it's PERMDAS. Any guess on what the R is? What do you think, David?
Roots.
Not roots. It means the same thing, but we use a different term for it. Eleanor?
Rational?
Not rational, because they're all rational numbers. David, is that what you're going to say?
I was going to say rational.
Okay. We call it radicals.
Radicals? That's like what we were saying, but in a weird...
No, radical is very different than rational. Rational is any positive or negative number that is a fraction, or that can be a fraction or a decimal that ends or repeats. So no, that is not the same thing as a radical. A radical is the square root. Right? That root number, what you multiply together to get something. So we're gonna come back to why that's important. What's the M? Ruby. Multiplying, that multiplication. What's the D? Claire? Divide. What is the A? Vivi? And what is the S? Amal. Subtracting. Now, these come in different levels. Our first level is just parentheses. You always, always, always look to see if there's a parentheses. You do the parentheses first. Our next level is exponents or radicals. An exponent would be like 3 squared. So 3 squared would be 3 times 3. Right? You just do it 2 times. You're multiplying that number by itself, however many times that exponent tells us. What do you think the opposite of squaring is? David?
Radicals, roots.
It's finding that root. Right? What number did we multiply by itself to get that? So the square root of 9 is 3. So the exponents and the radicals are opposites of each other. Okay? Our next level would be multiplying or dividing. They are opposites. 3 times 4 equals 12. 12 divided by 3 equals 4. Right? They work together. The same numbers, just going opposite directions. Same thing with adding and subtracting. 2 plus 3 equals 5. 5 minus 3 equals 2. So they are partnered up. So we have the level of parentheses. We have the level of exponents and radicals. We have the level of multiplying and dividing. And we have the level of adding and subtracting. When you are on a level, it doesn't matter which one of that level you come to first. So if we're on the multiplying or dividing level, if we're reading from left to right, if we hit dividing first and then multiplying, we divide first. We don't skip to multiply and then go back to divide. Same thing with the adding and subtraction. If we hit subtracting first, we don't skip it down to the adding part. We subtract first, then we multiply, or then we add. So if you're on a level, it's whichever one of the levels you hit first, going from left to right. You will get a different answer if you do it incorrectly. So an example of that, if I can find it right away, I can't find it right away. On what? Yeah, that's not what I'm looking for. That's just stickers. So on this example, we had 25 minus 7 plus 3. What would my answer be? $25 minus 7 plus 3. What do you think the answer is? Using the order of operations, what would that be? What do you think, Christina? How did you get 21? So 25 minus 7 is 18, plus 3 equals 21. I have had a lot of students in the past give me 15 as their answer. What mistake did they make? They said, oh, adding and subtracting, so I need to add, and then I'm going to subtract that from the 25. You get a very different answer. So our order of operations truly matters. 21 was the correct answer. They got it wrong when they put a 15. always have to think, if I'm on the same level, it's whichever one I hit first. Doesn't matter if it's the subtracting first. Because subtracting and adding are on the same level. So reading from left to right, we hit subtract first, so we subtract. Then we add. I'm going to erase this and move this one up. So that's what that means. If all the operations in the equation are on the same level, are the opposites, work from left to right. So now it says evaluate each expression and show all your steps. What does it mean when we evaluate an expression? Allie? Figure it out. You do the math. Okay, so when we see evaluate, we know we need to do the math. Then it says show all your steps. This is what I'm looking for. This is what I want you to do. And when we show our steps, we look at this and we say, oh, I have adding and I'm multiplying. I know what Perm does. I multiply first. So 4 times 3 is 12. I'm going to bring down the rest of my expression. And now I have a new expression, 12 plus 12. I know that is 24. I want to see you doing every step. I don't want you doing mental math and just giving me an answer. I want to see you bringing that expression down for the parts that stay the same. So for this one, I see dividing and minus and subtracting. I'm going to divide first. So I'm going to put what step I'm doing. 3 divided by 3 is 1. I'm going to bring down the rest of my expression. Now I know there's only one left. 1 minus 2. What is 1 minus 2? What do you think, Harper? Negative 1. Good job remembering it's going negative. Okay. Show your steps. Show how you're bringing down. Look at how I'm rewriting that expression right under where it was up top. Sometimes I have people with this one. They would say 4 times 3 is 12 plus 24. It's not 4 times 3 plus 24. It's 12, or sorry, plus 12. I wrote the wrong number. It's 12 plus 12. You have to write it the correct way. You have to bring it straight down. Why do you think I'm going to be kind of hardcore on this right now when it seems so simple and easy? Why do I want you to write it this specific way? Vivi? In the future, it's going to get more complicated. And if you know how to do it correctly now, when it's simple and easy, you're going to do it the correct way in the future. You're going to keep doing it the right way. I had some friends last year that fought me on this. They did not want to do it the right way, and it came time to the springtime, and we were doing more complicated math, and they struggled because they weren't following the steps. And I was really worried that when they got into algebra this year, they were going to struggle even more because they weren't used to following the steps. When I tell us to do something a specific way, it's for a really good reason. It is not me trying to make more work for you. I know what's coming. Okay. I know what I'm teaching this spring. I know what Mr. Schultz is teaching you. I've had algebra. I've had algebra 2. I've had geometry. I've had calculus. Okay. I know what's coming. And when I tell you to follow these steps, I truly need you just following the steps I'm giving you. I don't want to hear, but I can do it in my head. Yeah, I know you can. Some of these I can do in my head too, really easy. We follow the steps so we get in the habit when it's easy. So then when it gets to the complicated ones, we know exactly what to do. Okay? We do have a little bit more. Let's look at this bottom line. Let's look at this one. What do you think is going to be my first step? What do you think, Hadley? The parentheses, 4 plus 2. What is 4 plus 2? 6. I need to bring everything else in my expression straight down. So 6 minus that 6. I've got that exponent on the outside of the parentheses. That means that what's inside the parentheses, I'm going to square it. Divided by 3. What's my next step? Christina? The exponents. Exponents comes next. I've got exponents. I don't have any roots, no radicals, so I'm going to do 6 squared. What is 6 squared? Okay. How did you get that, Becca?
6 times
6 squared means 6 times 6. The exponent is 2, so we only have to multiply that 6 2 times. 6 times 6. It does not mean 6 times 2. I have a lot of friends who like to put 12 for that answer. It is not 6 times 2, it's 6 times 6. 2 times, right? So then I bring down the rest of my expression. 6 minus divided by 3. What's my next step? Ooh, I only have 2 people that know what the next step is. 6 minus 36 divided by 3. What could it be? Fallon? Division. I'm going to divide before I subtract. What is 36 divided by 3? Eleanor? 12. Now I'm going to bring down the rest of my expression. 6 minus 12 equals what? It's my last operation. I have to do it. Amala? Negative 6. I do every single step one at a time. Right? Every level. If I have the same level, I can do those together. Parentheses, there's 2 sets of parentheses. I'm going to do my parentheses, I'm going to do my parentheses, and then I bring down the rest of my expression. Okay? Then you solve it. Sometimes we will have decimals or fractions in our answer. We're in big kid math now. It's not always going to be whole numbers. So we know from our heading, it said, I can apply the order of operations on expressions with rational numbers. We're going to end up with fractions and decimals that end or repeat. All right, we're probably not going to have irrational numbers if we're working with rational numbers. Harper, did you have a question? What would we do first? What's the first part of the order of operations? So what's the first thing I'm going to do? Whatever's inside those parentheses, you do first. Then you bring down the rest of your expression. So even though it's adding, and that's not supposed to come before multiplying, it's inside the parentheses. That's how we get around that. You're going to finish this section. Well, let's look at our next section. Our next section, we're going to use those parentheses to our advantage, right? It says it's possible for each of these expressions below to equal 30, but not as they're written. If we did order of operations the way they are right now, we will not get 30 for our answer. 5 plus 5 times 3 would be 5 times 3 is 15, plus 5 is only 20. I need to make that equal 30 by using parentheses. I am not going to move any number. I am not going to move any operation. I am going to add parentheses. Can anybody see a way that we could put parentheses in there to make it equal 30? Robbie?
Put parentheses around 5 plus 5.
If I put parentheses around 5 plus 5, I know I need to do that first. 5 plus 5 is 10. 10 times 3 is 30. So we're going to look at all of those. They're not always easy. sometimes we have to really kind of struggle with something. I want to see us really working it through, trying to do the math and figure out how to make it work. I do not want to hear tomorrow somebody say, oh, I didn't do that one because I didn't get it. I want to see you trying. I need to see your effort on the paper to see that you were really putting forward the effort trying to solve it. Then on the bottom it says write 2 expressions, each with 4 and only 4 operations from PERMDAS. Make one expression equal to 25 and one expression equal to 100. It's like the 5-card challenge, but with only 4 cards. And the trick is you can use any operations, any numbers, as long as your final result is 25 and 100. But you can only do 4. Wait, no, if we did 4 operations, that would be 5 cards. So it's the 5-card challenge, but you get to pick your numbers. You have to have 4 operations in your expressions. Any questions on today's assignment? Quietly get to work. If you are watching this at home, I hope you are well, and I hope to see you soon. If you have any more questions, make sure you come see me. Don't forget to like and subscribe, and have a wonderful day.